Hello friends, so I welcome you to this course called Vibration Modeling and Analysis using Python. So I will take you through a brief introduction to this course and what is included in this course. So this is dedicated to mechanical vibrations and Python programs on specific topics. So it will be combination of theoretical equations deriving the equations of motion and based on that Python program from simplified level to complicated level. So let's start what going to learn. So this is a overall course outline in general. We will go through Python setup and some basic programming with Python which would be required for our topic. So this is specific to our topic from engineering point of view. Not all Python aspect we are going to study. Then we'll introduce to NumPy library. This is for numerical calculation, handling of arrays. Then Matplotlib library, which is used for plotting application like plotting the data, then graphs, 2D plot, surface plot, contour plots like this. Then we will go to the main topics like pre-vibrations. So pre-vibration of single degree of freedom system, we will derive some equation of motions and Python programs on it. Then we'll study harmonically excited vibration. So some kind of force vibration. Again, the pattern will be similar like equation of motion and Python programs. Then vibrations due to arbitrary force like step force or impulsive force, something like that. Then we'll study multi-degree of freedom system. Mostly we'll concentrate on 2 degree of freedom system. And in last we will study about vibrations of continuous system. So in that like vibration of bars and vibration of beams. So let's see in a quick manner what we are going to study. So in basics of Python program, NumPy and Matplotlib library, we'll cover some basic of Python programming like data types, conditional loops in the Python. Then in Matplotlib library, we will see how to plot such kind of graphs. Let's say this is a line graphs, 2D line plots, 2D contour plots, like where you have color combinations from equations, then 3D surface plot. Okay. Then we'll cover free vibrations of single degree of freedom system. So let's say we will derive general equation of motions for damped and undamped systems. In that there would be like under damped system, over damped system, critically damped system. We will see a plot response of damped and undamped system. We can see here damped system, undamped system. Then also we'll study some features like widgets in plotting where we can vary the values of some parameter and we'll check the effect of those parameter on response. Also, we'll study one interesting case where we will do iterative study or iterative calculation through Python program to calculate optimum combination of stiffness and damping for this lunar lander where we would optimize the period of vibration for this lunar lander. So you can see this kind of plots we'll study and we'll find the optimum combination of stiffness and damping values for this lander where we'll have specific time period of oscillation or optimized period. Okay, now in second part or second section we'll study about harmonically excited vibrations or some kind of force vibration where the forcing function in the form of harmonics like cos, sine, exponential functions. In that we'll derive equation of motion of damped system, undamped system. We'll study about magnification factor and bass vibrations. So something like vehicle moving on rough surface or bumpy road. So this is a bass vibration. Some Python programs related to this harmonic vibration. Then this is a magnification factor where we'll plot magnification factor for different values of damping factor and then phase angle for damping factors. Then we'll see one program for vehicle moving on a rough surface, harmonically excited vibration, and we will plot the displacement of the vehicle using this concept. Then we'll study about vibration of uh, engine engine part. So in this program we will plot the response of engine and the chassis. You can see this blue color plot is the response of engine parts, and this is a orange color is chassis response or displacement. So we will see how to do that with using principles of harmonic excitation. Then this is a one interesting topic, vibrations due to arbitrary force. So mainly we'll study about vibrations due to impulsive load. So how kind of vibration will be there and vibrations will vanish after how much time. Then what would be the response if there are multiple number of forces. So mainly we'll study about convolution integral in this section. So this is like convolution integral. If you are familiar, you can go through some books as well. Then we'll study about when vehicle is moving on speed breaker or road bump. We will see how to model that mass systems, mass spring damper system. Then we'll calculate what is the displacement of the vehicle, what would be the acceleration of the vehicle on the uh, vehicle on the when it passes through bump, and this is the response, sorry, this would be the response or vehicle displacement. Then we'll move to the multi-degree of freedom system. Mostly we'll study about 2 degree of freedom system. We will see how to calculate natural frequencies and mode shape. So we will use some libraries to calculate eigenvalue problems or natural frequencies, and we will also plot the mode shape for, let's say, multiple mass. So this is mass 1, mass 2, and what is the relative displacement of mass 1 and mass 2. We can get through that mode shape. Then this is a free vibration response of 2 degree of freedom system. So displacement of mass 1, mass 2. Then this is a force vibration response when there is a force in the external force in the system. Then the frequency response of multi-degree of freedom system. So there are three masses connected by spring and damper system. We will see how to use equations to get frequency response. So in that case we'll see at which frequencies we'll get higher vibration levels. Mostly those should be equal to natural frequencies. Then we'll go to the little bit complicated part, that is vibrations of continuous system. In that we'll study about vibrations of bar, one dimensional bar, mostly the longitudinal vibrations, and in vibration of beams we'll study the lateral vibrations of the continuous system. Then we will use FEA method, that is finite element analysis method, to solve the eigenvalue problems of bar and beam. So bar is mostly one dimensional part, it is subjected to only axial deformation. We'll see how to use FEA method, uh, like using one single element, multiple elements to calculate natural frequencies. Also we will compare with analytical results as well, whether our programming calculation is correct or not. Similarly we will do it for beam problems as well. So beam is little bit complicated. We will see how to get stiffness matrix, mass matrix, then assembly of those matrix to form global stiffness and mass matrix, and calculating the natural frequencies. So this is little bit complicated part we will see, and also compare those with analytical results as well. So whenever this is for up to this part, and continuously we will be adding content to the course, more and more advanced course that would be added timely into that course. So whenever or you can also suggest, let's say if you enroll, like you want to study on this particular topic, I will try to get some programs on that topics as well. Okay, so this is for introduction. We will start our course from next lecture. Thank you.